So hello everybody, welcome to SID306. This is how Chick-fil-A embraces DevSecOps on AWS. My name is Andrew Baird. I'm a solutions architect for AWS in our Atlanta, Georgia office. I'm pleased to be accompanied by Robert Davis here, who's going to be presenting the latter half of the presentation, who's from Chick-fil-A. And I, as a solutions architect, have the privilege and the honor of working with customers like Chick-fil-A down in Atlanta to help their teams follow best practices as they're building new applications, migrating existing applications, designing architectures on top of AWS. So with a development background like I have, the topic of DevSecOps is one that is a great topic I enjoy talking about, especially with security teams that are coming from a place where their existing practices and policies may not have been as modern as they need to be on top of AWS. So it's something that I enjoy talking about and hope you guys get some good information out of this session. So let's jump into it. The agenda we're going to cover, I'm going to go over a brief introduction for folks that are unfamiliar with the term DevSecOps or struggle to look at the three phases of that word and kind of interpret what it probably means. I'm going to go over a brief introduction. I'm going to make some bold statements, and then I'm going to give some kind of advice and prescriptions about tools that you can use to get started with DevSecOps if you don't have a practice already within your organization, and mention some key services to focus on as you get started. And then I'm going to transition the presentation over to Robert, who's going to tell the Chick-fil-A specific story as it pertains to DevSecOps. So by way of introduction to DevSecOps in one slide, it is kind of what you'd expect, but broken down of those three terms. Dev refers to the idea that your security team is going to be developing software. You're going to follow the same types of tenets and principles and processes that your application teams do. This isn't, a hacky side project that you're, kludging together some code for, some scripts together. If you want to be, following DevSecOps, your security team is going to be developing real application software. The difference is where the sec comes in. The purpose of that software and the focus of it is going to be security focused. It's going to be about monitoring your environment, enforcing policies, ensuring that the security policies that your organization has set forth are being followed by your applications. And it's going to sit within the operations scope of your organization. It's going to be running alongside application code. It's not necessarily embedded within applications. While obviously you want all of your application teams to be following your security policies and best practices within their application code, the software you're going to be writing as part of DevSecOps is going to be running within on the perimeters of your accounts, performing things like monitoring, auditing. It's going to be automating a lot of security decisions within those accounts. It's going to be embedded within the different processes to make them more automated. It's not going to be within the code itself. So DevSecOps, quick little introduction overview to kind of what we're referring to through the rest of the talk. So I'm going to make some bold statements. Some will be bolder than others. They're not meant to ruffle feathers. They're just meant to kind of set the stage for the rest of the talk that Robert's going to give and kind of define a little bit of the stakes that are at play here. To give you an idea of the importance of revolutionizing and modernizing your security organization through the DevSecOps kind of tenets. So the first statement, hopefully it's not too bold. If you want to follow DevSecOps, your team actually must write code in order to be practicing DevSecOps. And that's not just to be pedantic about the term DevSecOps. There's a lot of value you can still get out of security automation using tools that can automate things without having to write code. But if you want to be practicing DevSecOps, you really need to be using higher level programming languages and writing real code. And the reason for that is every organization that's present within the room, every application that you guys are deploying has some level of uniqueness to it. The policies that you have are going to be different. And if you can find an off-the-shelf tool, as automated as it allows you to be, that solves all of your security policy concerns, that's great, but it's not as realistic as you probably think it could be. So there's going to be policies that you want to enforce that are specifically catered to your organization's policies and your practices, that being able to actually write specific code and logic to perform those enforcements and monitoring is really important. So the only way you're going to be able to achieve those things is if you're willing and able to write code that specifically addresses the biggest concerns that you have within your AWS account. A slightly bolder statement is if your application teams are practicing DevOps or embracing automation on top of AWS and you're not practicing DevSecOps, your security policies are a bottleneck. So think about the amount of agility and the amount of elasticity that we've enabled through all the different services that AWS has to offer for your application teams. If you set forth policies and practices as a security organization that puts really tight guardrails, whether it be from the features they're able to take advantage of, whether it be for the processes that they need to go through in order to gain approval for things like deployments or security group changes or provisioning new infrastructure. If you're not embracing DevSecOps and you have a lot of manual processes that still exist, your practices can become the bottleneck. And the reality of the situation is that previous to all of that elasticity and agility existing for your application teams, when development was more waterfall-centric, infrastructure procurement times could take weeks at a time. Security teams had a lot of lead time for when, requests would come in to say, we're working on a new application, its launch date's going to be, 8 weeks from now, we're going to need this firewall port open, 6 weeks from now for testing. And you had a lot of lead time, but today, your application development teams are going to be wanting to make decisions in the morning and have them implemented within their account, by lunchtime. And if you have a lot of manual process in place without the code and automation to kind of assert your security policies for you, you're going to create bottlenecks that's going to create a lot of friction within your organization. So writing code and building tools to be extensions of those decision-making processes through DevSecOps is the way to still maintain the security bar that you'd like to maintain, but allow your teams to have the agility and embrace the automation that they want to embrace. Probably the boldest statement I'm going to make is that if your applications do run on AWS and you're not practicing DevSecOps at all, your security bar is frankly just not high enough, and it's not as high as it should be. And the reason for that is thinking about all of the existing processes you have for security policy that may have been pretty paper-centric and process-centric to define, what types of infrastructure must be encrypted and what's the process for changing firewall ports. Those types of processes and the amount of lead time that you had baked into them is not the same speed with which malicious actors are working with today. You need to be able to have software systems and tools that are able to react at a pace that's hasn't been seen previously with the way that you were approaching security prior to the way that infrastructure is built and automated today. So if you want to actually still achieve the same security bar that you had previously, but you're building in an environment that's as elastic as it is. The only way you're really going to be able to achieve that is if you're writing code that's able to 24/7 evaluate the environment changes that are occurring and assert the decisions that your security policy is set forth in a programmatic way. Just think about the types of changes and the speed of changes that used to occur within an environment where you may be making a couple firewall changes every month. A lot of organizations have specific days of a month that's the day they make firewall changes. And in reality, on top of AWS, depending on how your applications are designed, you could have teams that are creating entire new virtual data centers in their VPCs on a daily basis. And the idea that you can have the same type of security approach to assert your policies when that type of dynamic infrastructure changes are occurring is just something that doesn't scale anymore. So DevSecOps is really the way that you as a security team can continue to enforce the policies you have at the rate with which infrastructure is changing within your AWS accounts now. Okay. So where do you start? So you kind of see you see the value and the need and the necessity to write code to maintain your security bar. It's a broad problem. There's a lot of places you can begin. It can be, it can feel a little overwhelming at times. That's one of the, double-edged swords of working within IT, that you need to be continuously learning. The space is always evolving. So where do you start if you want to begin adopting DevSecOps? So taking the first step really involves kind of what you'd expect, choosing a programming language that you want to standardize on. So it's really important if you're a security organization that has multiple teams to get down to a level of standardization across those teams, or at least within a single team, so that all the tools and the systems that you're going to create are going to be easily understood by everybody else on that team. You're going to come up with good best practices for that specific language, as libraries that you prefer, reference code that other future tools can use. If team members, change teams within your organization, it can be easy for them to, not have as much friction to pick up new languages or skills. So it's really important to standardize on a language. And if you are considering which language to adopt, we've got a couple kind of deciding factors here to point you in one direction or another. If you have skills existing on your team already and tools that exist, obviously you can continue to use those. If you're just getting started, I really recommend Python as a great place to start. I think our Python SDK, the Boto 3 library, is one of the easiest ways to integrate and interact with our services out of the gate. So an interpreted language that allows for real coding speed and flexibility, a great SDK. Python is a great place to start if you don't have an adopted language already. All right, so you've got your language. You want to know, what do I focus on? I've got to write code to make decisions about my policy. Where do I want that code to assert decisions for me? So I've got these things defined. So the things you're going to code with are that Python SDK described, or whatever your SDK for your language of choice is. For any gaps that exist within the SDK as new features come out that aren't included yet, you look at the CLI or the AWS APIs directly. And then to actually architect your systems, deploy them, manage the code that's been created, you're going to use these services in the middle. So AWS CloudFormation is your infrastructure as code service, so that all of the software you're creating as a security team that you'd like to be programmatically deployed within all of the other AWS accounts that your applications run within, CloudFormation will programmatically provision it for you. EC2 Systems Manager is a great service. It's really powerful and free on top of EC2 that gives you the ability to remotely execute commands, so shell scripts, PowerShell scripts within those hosts. Check patch status, assert version compliance for different software packages. A lot of cool stuff that's security centric. AWS Config is a little bit analogous to your change management database on top of AWS, where you get to see the history of all the configuration for your resources on top of AWS, and you can evaluate the compliance state for all those resources. CloudWatch, everybody should be pretty familiar with if you're using AWS for your metrics and monitoring, so creating alarms and alerts based on the state of your infrastructure is a great place to pull from, and creating CloudWatch events as resources are created is another great way to start with security. CloudTrail is your audit log of all the API activity that's happened inside of your AWS account. And AWS Lambda is for all of the software you're going to write with Python, or your language of choice. A lot of security teams don't have the large operational budgets and operations teams to manage the tools that they create and maintain them. So building serverless architectures that really greatly reduces the operations requirement to, you don't have to patch servers, you don't have to provision, you don't have to scale. It becomes a really lean way for security teams to build sophisticated security systems without introducing all of that operational burden. So you'll use those things in the middle as a way of architecting and provisioning the tools that you create. Now the code that you're going to write, that you're going to manage and enforce and build with those middle services, what do you want to actually assert decisions about? So these 4 items on the bottom are just chosen as typically mission-critical security-centric features within our platform that security teams often care most about. So all of the IAM policies and roles that exist inside your account, all of the S3 bucket policies to ensure that any buckets that should not be public continue to have policies that don't make them public. That if there's particular whitelisted roles that have access to a bucket, that it's defined in the policy and that doesn't change. Security groups, obviously your firewalls on top of EC2 are of great importance to security teams. And then finally VPC and all of your network architectures. So kind of choose this as a choose your own adventure type of board where you're not going to begin with all of these things at once, but think iteratively. The more you try and think about the amounts of software you could write to greatly increase your security bar in AWS, the more overwhelmed you're going to feel. So just like everything in AWS, one of the big value propositions is to be able to build and think iteratively. So choose one of those things at the bottom that you consider, the thing that keeps you up at night the most. You've got extremely mission critical, private customer data in S3 that you want to make sure is never, accidentally, configured to be available to the public. You have a security group that's tightly restricting access to an old, data center application that's, crossing a VPN between AWS and your data center. An IAM policy that defines admin rights for who's able to, access whatever's important inside your account. Pick the thing that's got you the most concerned and write a little bit of code in Python, create a Lambda function, and manage it through those services in the middle. and just start iteratively, and you'll be surprised how quickly the ball starts rolling downhill as you gain new skills to learn how to deploy these things. So just pick the thing that makes you most concerned and write a little code that will help you sleep a little easier. And that's really where I'd kind of recommend you start. So as you kind of go along, there's a couple places where you don't have to start from scratch on your own. A lot of great organizations have open source projects, and AWS itself has made available some additional libraries and prescriptions for you, and these slides will be available if anybody needs them. So the SIS Foundation benchmark, we have a great code repository that deploys a CloudFormation stack within your account to help evaluate the state of your account. You can kind of see the code that's written, how it's doing its evaluations. Cloud Custodian is a really awesome open source project from our friends at Capital One that has a slew of different capabilities around CloudWatch events and Lambda functions to define compliance within your accounts and report status of that compliance. Config rules and config is a service that I've mentioned already, and there's a great repository that we've published of a slew of example config rules written for Lambda that can evaluate different configuration changes within your account. And then finally, we have a security blog where a lot of the solutions architects like myself and customers, as new features come out, will have a lot of great blog content and tutorials there that you'll be able to kind of see as new services come out and new solutions are thought of and created to walk you through example architectures and solutions for you to, as a security team, get ideas for what's valuable to you and your organization that you should implement yourself inside your account. Okay? So with that, I'm going to transition it over to Robert. He's going to give you an overview of Chick-fil-A's security journey.
Mike? There we go. Sorry. All right, thanks, Andrew, and thank you all for coming today. Just to hear a little bit about our DevSecOps journey with Chick-fil-A, so I really appreciate you taking the time. So our journey really began a number of years ago, but before I dive too deep into that, I want to give a quick intro into Chick-fil-A and who we are in case you have not heard of us. Chick-fil-A is a quick service restaurant. We have the best chicken sandwich you'll ever eat in your life, guaranteed. But on top of that, we have really, really good customer service, and the quality of our food is the same no matter where you go. There are, I believe, 3 restaurants here in the Vegas area, so if you've not tried us, please do, and give me any feedback you want on that. Appreciate that. Intro on myself, I've been with Chick-fil-A for roughly 13 years. Started as a network engineer and moved into security about 8 years ago, doing some firewall administration, engineering work, and now I'm currently leading our security engineering and incident response group. So our journey with AWS really began over 5 years ago. And we had our monitoring team who said, I need to be able to scale up a bunch of servers to monitor all of our managed servers. So they had more servers monitoring than they did in the managed data center, which didn't make sense to me, but they wanted to do it anyways. And we didn't have the resources to really understand public cloud and AWS, and specifically from a security perspective, how we were going to do it. But we had to make a compromise. We said, okay, you go do it, but you do it on your own. Fast forward a few years, and I'm starting to understand public cloud a little bit more. It makes sense. I like it. Once or twice a year in the IT department at Chick-fil-A, we have what's called an innovation day. So we coin it Spike It. So we have a 24-hour innovation day. And a couple years ago, Andrew and I participated in one of these teams, and we were trying to take an existing back office application for our restaurants and turn it into a serverless model. And that really piqued my interest. What's this serverless thing? What is this Lambda deal? What does that mean? And I learned a lot about AWS, learned a lot about Lambda in particular, and it really sparked a huge fire in me to say, we need to move forward with AWS from a security perspective because I can be more secure in that world than I can in my existing world. Now, you can also be way more insecure and less secure if you don't do it right. But if you do it right, you can be, in my opinion, more secure than you could in a managed data center, at least for us. On top of that, the shared responsibility model really was interesting to me because it meant that AWS would handle a lot of the things that I currently had to handle from a security perspective. And they've got a lot more people to do it, and they're probably better at it than I am. So why don't I just leverage that? So that's what we did. So now that we've decided organizationally that we're going to move forward cloud first kind of mentality, AWS specifically, we needed to come up with an AWS security strategy. And with this strategy, I didn't want to repeat the old mistakes that we make in the managed data center, specifically around network segmentation. If you look at a lot of the breaches, a lot of these major breaches occur because improper network segmentation is in place. Because traditionally, you stand up a network, it's very flat on the inside. You've got your client network that has access to pretty much everything in that network. Some people have segmented a little bit better than others, but ultimately, lateral movement is one of the keys to preventing breaches. So if you can stop lateral movement, you're going to make it much more challenging for the malicious actors to actually compromise your network in any significant way. And so out of that, and out of really watching a lot of reInvent talks from 2015 and some last year, I decided that the best strategy going forward was the multi-account strategy. Using multi-accounts and having an AWS account as a security boundary for us meant that lateral movement becomes extremely difficult. And it means the bad guys now have to retool almost everything that they're doing from a breach perspective, which means we're winning in some ways. Now, they're going to catch up, which means we're just going to have to innovate and do something different. But for now, that puts us in a better position. A term I heard a lot with these previous reInvent talks was blast radius. I like that term, so I'm going to say it. I love having a small blast radius, which means every AWS account itself, while we're not one-for-one, meaning one app per account, we are trying to get closer to that, which means every workload we have has a really, really small blast radius. So if there's an issue in one workload, it doesn't impact all the other workloads around it. So today we've got roughly 58 accounts and growing. We have a central security account that has assumed role rights into every other account. And that's how we, from a security perspective, lay out policies, remediate certain issues, have visibility into them, et cetera. We also decided that in order to do AWS properly, every control we put in place had to be scriptable and had to be repeatable. And so to Andrew's point, we had to learn how to code. Right? We're not developers, we're security guys. I do come from a computer science background, but I haven't really done a whole lot of coding over the last 10 years until AWS came around. So we chose Python. It's easy to learn, easy to read, which means somebody that's coming new into the programming world and learning how to script and code, they can pick up something and actually follow it pretty easily. So just from that alone, I thought Python would be a good choice. And then just so happened that Boto3 was also an extremely robust package to use to interact with AWS. So everything we wanted to do from a security perspective had to be somewhat event-driven as well. I didn't want humans to have to be in the middle of anything that's happening from a security perspective. It had to be event-driven, and it had to be auto-compliant. And then last, serverless. The idea of a security team having to manage an operating system so that they can build an application on top of it did not sit well with me. And after learning about serverless, I said we have to do it serverless. Whatever we do, we have to find a way to make serverless work. If we can't, then it's probably not the right tool for us, one. And two, we're going to end up wasting a lot of time. So let's not do that. So when you go to multi-account strategy with AWS, you have a number of challenges that you're going to have to overcome. And the tooling's not quite there for some of these challenges. And so we had to kind of build our own. So I'll walk through some of those challenges here, talk about some of the tooling that we've produced and built, and just share some of that knowledge with you. So we had 5 really big challenges. We had account creation challenges. If we're going to do multi-accounts, how do you create accounts in a scalable way? You had CLI or SDK access. If you have multiple accounts and you have developers and users that have access to 20 accounts, well, how do you give them CLI and SDK access without having to provide IAM users in every single account and give them long-lived credentials, which is just a recipe for disaster? You had visibility issues. If you have 10, 20, 50, 100 accounts, how do you get a high-level overview of what's running in those accounts? How do you get that level of visibility from a 10,000-foot view? Auditability, similar to visibility. You have 10, 20, 50, 100 accounts. How do you make sure that every one of those accounts is compliant and adhering to your security standards? And then finally, developer enablement. One big paradigm shift for me mentally from a security professional standpoint was learning to have to trust developers They're going to have to go really, really fast. They're going to go really, really fast. And if I don't trust them to do the right thing, or I don't think that they're capable of doing the right thing, this is not going to work. So we had to come up with some ways to allow developers to do what they want to do, allow them to build, but do it in a secure way. So now that we have these challenges in front of us, we had to come up with some, we call it tenets of DevSecOps for us. Number one, automation. It has to be automated. We can't have a human involved in whatever we're doing. So we automate as much as we can. Two is event-driven. So again, it has to be event-driven. I want actions to occur and immediately be able to take some other remediation step or alert out of that action. It has to be serverless, which I've already mentioned. If you can't tell, I'm a huge fan of serverless. Enabling agility without compromising security. Again, put control in the developer's hands and let them do what they do best, and that's build. Do that in a way that they learn. If they make a mistake, they learn from it, but we are not the reason in the bottleneck for their app to not get deployed. All right, so our first challenge, account creation. If we want to leverage multiple AWS accounts, we must make it easy to create new accounts. If anybody here has ever created an AWS account and done it the old manual way, you feel my pain. But if you create 50 accounts the old manual way, you know it's not going to work. This started as a manual process for me, walking through the web form and putting my name in, putting my email in, putting my credit card in, waiting for that phone call, getting that phone call, putting the PIN in. That worked, but there's no way that's going to scale. If you do multi-accounts, you cannot do it manually. You have to script it out. And I didn't know where to start. I had never scripted anything against a website before, so I didn't have the first clue how to do this. There was no API for me to leverage, so I couldn't do that. Well, I happened to stumble across into its AWS Account Utils Ruby project. And this, so I'm not a Ruby developer, so my first thought was, well, I need to move to something different because I have no idea what to do with Ruby. But instead, I took it and I said, okay, I can at least read the code. So I started reading through it, and it started to make sense. Oh, okay, this is what you need to do in order to automate this account creation. Okay. So I took what they did, got some tidbits out of that, and I decided to do it in Python, because that's what I know. And I used the Selenium package to do this. So we scripted out this big thing in Python. It was at least semi-automated, still not perfect, but pretty good. Luckily, a year ago, organizations, so AWS Organizations was announced last year. And the one huge part of organizations that made me say, I absolutely have to do that, is a simple API to create an account, which I'll talk about in a bit. Now that we have scripted our account creation process in some ways, we have to integrate with ServiceNow to allow for some self-service. So if you're going to do multi-accounts, you want to make it kind of easy for a business user or an account owner to create an account, or at least start the process. So we integrate with ServiceNow, it kicks off a flow, and we go and we create an account off of that. So like I was talking about before organizations came out, it was a Python script using Selenium. It was over 500 lines of code. I constantly had issues with it, and that's probably my poor coding plus some other things. But web browser version issues was always an issue. If I upgraded Firefox, it blew up in my face. I had if there were ever any small changes to the web form that Amazon used for the account creation, it all blew up and I had to go fix it. It wasn't easy to run in a headless mode, which means there always had to be somebody at a command line running the script, waiting for certain responses, following up, etc. I still had to have a credit card, so my credit card's on like 30 accounts. I've removed it now because I didn't want to get a $10,000 charge for somebody going wild on S3. But with that credit card, I didn't want to do that anymore. Human verification, you still had to sit there, which means I could never fully automate it, because somebody had to be there to answer the phone, put the PIN number in, and do the human verification over the phone. Well, then came organizations. And with organizations came a simple API to create an account. So my 500 plus lines of Python code, working through Selenium, doing all the web form junk that worked 60% of the time, boiled down to really like 15 lines of code. So it's a simple create account API call, and then a describe create account status to figure out when it's done. So it takes a couple of minutes to run through this for an account to get created, but ultimately it works every time, and I don't have to worry about trying to fix it. So now that we've figured out a way to actually create accounts in a scalable way, we need to make sure that every account we create has a standard templated security set, right? We need to make sure that every account we create has every policy that we need in place from a security perspective, so that I know when I hand the account over to the account owner, it is ready for them to use, and I don't have to follow up and do some other security policies or changes. So I looked at CloudFormation to do this first, and a year and a half ago I wasn't really good with JSON, and there were a lot of kind of shortcomings with my skill set to work with CloudFormation, so I fell back on Python, and I scripted it out instead. And so this script will do things like create a standard VPC. All of our accounts has a standard VPC, and that standard VPC is 4 tiers. There's a public tier, an app tier, a data tier, and a management tier. And those 4 tiers have network ACLs that are associated to them, and each network ACL is specific to its tier. And then there's a standard set of security groups for each tier that a developer can use if they don't want to create their own security group. That makes it simple. Then on top of that, we bootstrap a Bastion server in these accounts. So one thing I didn't mention about our multi-account strategy is there's no direct connectivity between any of these accounts, and there's no direct connectivity between these accounts and the managed data center. We don't do VPN connectivities except for a few exceptions. I really, really, really wanted to make that blast radius as small as possible. So we had to come up with some creative ways to at least give somebody access into these environments. So one of those was creating a Bastion, bootstrapping these Bastions in every account that we have. And we use Duo for multi-factor, and Duo has an SSH plugin. So we have multi-factor on every Bastion in every account out of the gate. So we never have to worry about somebody getting access to infrastructure without going through some form of MFA, which is pretty cool. Then on top of that, we create a standard set of IAM federated roles. We don't like to use users. We don't like to create IAM users in every account. With 58 accounts, if you have somebody who has access to 10, 20 accounts, creating users in each one of those accounts is just a nightmare. So we leverage IAM federated roles. We use ADFS to do the SAML federation between us and AWS. And then we control access to those roles via Active Directory. So if there is a user with access to 20 accounts, it's just add him or her to the Active Directory group associated to that role. And then we set IAM user password policies. Even though we don't like to have IAM users, there are exceptions to the rule, obviously, and I want to make sure that the password that is associated to this user to allow them access to the console is set to a standard that we put forth. And then we create a security audit role in every account. That audit role has a trust with our main security account that allows that account to assume into any other AWS account and be able to pull information about that account without having to actually have a user or role defined for a security professional there. Then we enable AWS CloudTrail. CloudTrail is your best friend from a security perspective when it comes to AWS. If you're not doing something with CloudTrail from a security perspective, you are doing it very wrong. Definitely enable CloudTrail and follow along with that. Then we set up Amazon CloudWatch event rules. So Amazon CloudWatch event rules allows us to kind of put some developer guardrails in place, which I'll speak to later. But that's how we enable our developers there. And then the last step is to register the account with our security account register. It's just a Dynamo table that we store some metadata about every account in to allow us to be able to automate a lot of the things that we do. Okay. So that's account creation. So our next challenge was CLI or SDK access. If we have developers with access to 20 accounts in some instances, how do you do that? So if you want to leverage multiple AWS accounts, you must make it easy to access these accounts. And this one was a difficult one for me. I didn't really know where to start, but being a consumer of the AWS Security Blog, I stumbled across this perfect blog for me in this time. How to implement federated API and CLI access using SAML 2.0 and ADFS. Perfect. That's exactly what I need. That's exactly what I need, and that's what I'm doing. So I went down that road. I followed the blog. I took the script that they that they had in that blog, and I ran it in our account. Oh, we're doing Duo, multi-factor. Well, this blog didn't take that into account. So I had to figure out how to make Duo work in this same scenario. But once I got it working, there's two really, really cool things that came out of this. One, MFA is enabled for everyone that has console access or CLI access by default because of the federation. Everybody. That's awesome. Second, there's no long-lived IAM credentials on developers' machines. Now, there are exceptions to that, of course, but 99% of the time, that means we don't have to worry about a developer committing code that has an API access key that can then be used because it's long-lived. These STS creds live for, I think, roughly an hour, so that key is not good for very long, which means we don't have to worry about those issues that you hear sometimes in the news. This is an ugly screenshot, but as you can see, green text, black background means I'm elite hacker. So what does it fall along here? AWS login, once you put your username and password in, you see the push notification. So I get a push notification on my phone for Duo. Click yes, this is me, and then I get a list of all the roles that I have access to. I can select any one of those roles, and now I have access from an SDK or CLI perspective into whatever role or account I'm choosing. Those creds get put into the AWS credentials file. So that's how that works. Now, if you have access to multiple accounts, and you want to actually be able to use the credentials profiles across those accounts at the same time, we have the ability to actually add a profile argument to say, this profile is prod, this profile is dev, this profile is test, etc. All right, our third challenge, visibility. This was arguably the biggest challenge that I had because I had no idea how I was going to solve it. But I think we came up with something pretty cool that I can't wait to share a little bit about. And hopefully at the end of it, eventually in a couple of months, we'll open source this tool, which will be our first kind of foray into open source software. So we're working through some legal stuff. But all right, so account visibility. If we want to leverage multiple AWS accounts, we must make it easy to see into all these accounts. I didn't know where to start with this. There's no good, easy way with AWS using a multi-account strategy to do this. Organizations eventually could be it, but right now it's missing some of the crucial functionality that I need for this to work. And so outside of that, doing some just general research on serverless, because I really love the serverless idea, I stumbled across this completely not related to visibility at all, but I stumbled across a demo app from AWS called SquirrelBin. I don't know if anybody here has ever seen SquirrelBin or messed with it, but it is a really cool way to learn about the serverless architecture. And at the end of it, you've got a serverless app running an Angular site with RESTful endpoints for the data. Oh, that's how single-page apps work. Okay, now I'm starting to pick up some steam. And then I had a thought, well, okay, why don't I just build a single-page app using the same architecture, but instead of you putting in these little squirrel tidbits, you end up getting information about all 58 of our accounts at once. So that's what we did. So we went down the path of creating this single-page app. And after we created it, you had things like you could quickly search across all accounts for IAM users that had a password. Okay. Now, without automation in place, that's good to know. You can follow up and you can say, you have a password on this IAM user. That's not something we really like. You either need to change it or give us good justification as why you need it. You can also do things like get counts on resource types. How many EC2 instances do we have running in 58 accounts? Well, we can do that easily with this app. Same with RDS instances and IAM users and security groups and public IPs. So we have all these things that get pulled into this single app so that us, the security team, or our ops folks can have a quick, easy view into all the accounts. Okay. So architecturally, it's really it's a single-page app running Angular, API gateway to Lambda for all the app logic. There's no persistence layer here. I'm pulling all of this information real time, which is neat, but also provides its own set of scale challenges, which I won't talk to too much here. But The only persistence layer we really have is some account metadata. So we have some high-level metadata about every account. Who's the account owner? What's the account alias? What's the account number? How many admins are in that account? That sort of thing. That's the only layer of persistence in this app. So this is the architecture diagram. This is what this app looks like. So you can see everything is funneled through API Gateway. Originally, it was CloudFront S3 for all the static content, and then API Gateway for all the RESTful endpoints to bring in the data. And that worked a little bit, but I wasn't a huge fan of my client-side application being accessible to anybody in the world unauthenticated, right? Even though there's nothing really sensitive in the app, I just didn't like the idea. So I funneled everything through API Gateway. I said, all right, we're going to go through API Gateway. I can at least put a custom authorizer on things and at least know that in order to get to this app at all, you have to be authenticated. There's one small portion of this that is unauthenticated. It's basically the login portion of it. So when a user logs into this portal, I'm using Cognito and Cognito federated user pools to do SAML authentication, federate against ADFS again, although we've recently switched to a different IDP. But you go to ADFS, you get logged in, and then from there, everything is driven through the ID token, through the OAuth flow in Cognito. So the only part that is not authenticated is the login piece, and that's where you get redirected to after you've successfully authenticated against ADFS or Okta. Once you've hit that, then you've got full access to the app. All right, so at the top, we've got accounts metadata. This is just kind of, here's an overview of all the accounts running in your environment. Here's the user, or here's the account owners. Here's the technical managers. Here's the email associated to the account, et cetera, et cetera. And at the bottom, you've got a large set of lambdas that act as the API endpoints for the RESTful calls. And those lambdas will do an IAM assume role into every account that we have, and then pull back the relevant information for the application. So initially, we looked at leveraging a framework like Zappa, and Zappa is really, it's a very nice framework. My issues with Zappa were there was almost like this monolithic lambda, which for me made it hard to debug and troubleshoot, harder to read. So instead, we just broke it out. So literally every API has its own lambda associated to it, which makes it much easier. And since I'm terrible at unit tests and that sort of thing, I know I can make changes to this app, and it's really only changing one small API endpoint, and I'm not breaking anything else. So I can do whatever I want, which is nice for me. So that's the architecture. Here is a horrible screenshot of this app. And the reason this is so horrible is because I thought I would be able to have true test data available for reInvent, and I could almost kind of demo this. The problem is, since I'm pulling it live from actual accounts, there's no real good way to do that, at least not in the time frame that I was trying to squeeze this in. But this screenshot here is just an overview of what the accounts page looks like. So you've got account number, alias, email, owner, and we have this remediate flag, which I'll speak to a little bit later. But that basically, with that flag set to true, it means any event that occurs that we deem non-compliant, we auto-remediate. So if you click on that account, you then dive into the single account view of more specific information about this account. So inside here, you can see the list of instances, users, databases, Dynamo tables, S3 buckets, et cetera. You can see that we have 9 admins in here, which is a non-compliant account for us because we were only supposed to have 4 or less. You can see we've got 24 public IPs in here. That's a decent amount of public IPs. This account may be a little more risky than some others. So just from this quick view, you can kind of make some assumptions about the account. And then on the this far side here, this assume role button or link, for me, when I need to access any account, instead of having to go figure out, okay, what's the account number, what's the account alias, okay, I need to go log into the console, and then from there, I can assume. I can just assume straight out of this app, which makes it much more convenient when you're talking about 58 accounts and trying to keep track of everything. All right, so that's the visibility challenge. Next is auditability, which is similar, but a little bit different, right? We want to be able to audit all of our accounts to make sure they're adhering to certain standards. So if you want to leverage multiple AWS accounts, you must make it easy to audit all these accounts. So we went down a road of trying to build a compliance rule engine. I looked at config, and config had some pieces that I liked and could probably work with, but config gave me some challenges when it came to multi-accounts, and so I kind of put it on the side. I'll probably revisit it at some point, but for now, instead of using config, we're just going to build kind of our own little rule engine and run that instead. So this rule engine does things like it'll check all instances in an account and see, does it have a public IP associated to it? For us, that's non-standard. It's against our security practices to put a public IP on an EC2 instance. Instead, you should be fronting it with an elastic load balancer in the public tier, and the instance should be in the app tier. So that's non-compliance, so we look for that. We check IAM users for non-compliance. IAM users shouldn't have a password set because that's just not what we prefer. We prefer roles over users. So we check for that. We check for S3 buckets having global access. AWS is making it a lot easier to actually get this information now in the console, but so we'll check for that. We run this report daily right now, but it can be run on demand out of that portal that I showed, the single page app. So architecturally, all this is a set of Lambda functions that run via CloudWatch event schedule. It's really just cron jobs. So those run once a day. They go into every account, so all 58 of our accounts. It'll look through those accounts. It'll pull out the non-compliant resources, put them into a JSON object, and throw that into S3. And then from there, we can pull it out of using that single page app. We can pull it out of S3, and we can visualize it in some way to get an idea of how non-compliant is a particular account. So we're still building this rule engine out. It's got a long ways to go. But ultimately, what I'd really like to get to is to a point where our compliance team can build their own rules instead of us having to code it. We just have to give them all the appropriate variables for certain resources. And then they can go through and do things like, well, give me an EC2 instance that's in the public tier, or give me an EC2 instance that's in an app tier with a public IP, and that sort of thing. They can start to build their own rules. So that's where we'd like to be. It's going to be a bit till we get there, but I think it's got a lot of promise. This is a quick screenshot of what that portal looks like and our compliance audit report. You can see 392 EC2, non-compliant EC2 resources. That's because our rules engine's broken right now. But don't worry about that. We're not that bad. All right? We're still pretty good. All right, so that's auditability. Then our final challenge was enablement. So how do we let developers build without us being the reason they can't build something? Right? I don't want to say no all the time, just most of the time. Just kidding. If we want to leverage multiple AWS accounts, we must make it easy to enable developers to be secure by default. Right? We have to trust developers. We have to get over, from a security perspective, we have to get over the fact that we don't trust developers to do the right thing. Most developers want to do the right thing. They just might not know what that right thing is from a security perspective. So we have to teach them. But you can't sit down with them and actually go through and teach them, this is what you need to do, here's where you need to put it. No, you let them make the mistake, you remediate it, they won't make that mistake again. They'll do it right the next time. So that's what we decided we were going to try to do. So we leveraged CloudWatch event rules to do this. So we're kind of still working on a name, but we're kind of calling this guardrails for now until we have a better name for it. But what guardrails is going to do is you're going to set up a CloudWatch event rule, and those rules are going to trigger off of what we consider interesting API calls. So if you think EC2 instance, EC2 run instances, that's an interesting call for me because that means there's an instance being created. There's a lot of misconfigurations that somebody could do when they create an instance. They put it in the wrong subnet, they put a public IP on it, they associate a security group to it that's open to the world, that sort of thing. So we can check that through CloudWatch events rules. Okay. So anytime, I mentioned the remediate flag in the table before. If something is set to remediate, and today, since I don't really trust my code, we only remediate in dev accounts. In the future, I'd like to see it in prod, but today it's only in dev. But the use case of a developer creating an EC2 instance in the public tier with a public IP, the moment that happens, CloudWatch events triggers, This triggers our flow to check compliance of that instance, and then remediate if it's non-compliant. So remediate in this case is to terminate. So we will terminate your instance. And then we'll send an alert or an email to you to say, we terminated the instance, here's why. And, don't do that again. And eventually they learn. They learn, oh, well, I just wasted my time creating this instance, so I walked through the entire flow on the console, and I created an instance, and then they just blew it away. Maybe I need to do a little bit better next time. So they learn by this, which is really cool. So for the accounts that are non-remediated, so our prod accounts in this case, we actually create an event or a ticket in our incident response tool. We have a security analyst follow up with the account owner or the user that created the event and make sure that they at least did it purposefully, so it's non-malicious. And then we have our audit and compliance group that can follow up later and say, okay, this is a non-compliant resource. Please give me a good reason why. If not, we need to do something about it. And then in order to be developer friendly, I needed to integrate with things like Slack. So we built just a simple webhook to at least post the incident into Slack since nobody checks email anymore, myself included. Can't stand it. Too many emails. So we use Slack for that. Ultimately, I'd really love to make this more developer friendly in that the moment an event occurs and it triggers an alert or a remediation, that goes into Slack as a Slack app of sorts that is interactable or interactive. And so the developer can say, yes, this was me, and here's why I did it. Or, no, this wasn't me. Or, I'm sorry, I won't do that again. One of those options, any of them is better than the back and forth of following up on email and trying to make sure we get the right person involved and that sort of thing. So here's a architecture diagram of what this guardrail system looks like. So on your left is the security account, so central security account. In this account, on your left. Right, left, okay. This security account is the account I mentioned before, and it's got a few components in it. So we've got an SNS topic with a Lambda subscriber. That Lambda is our CloudWatch events catcher. It's just a generic, give me the message and I'll route it to the proper Lambda function to do the remediation and compliance check. We have a Dynamo table that just keeps track of the compliance history and all the events that occur. And then on the other side, all of our other AWS accounts, the setup is super easy. It's a very easy CloudFormation template that sets the CloudWatch events rules with the interesting APIs that we care about and those API calls. And then a very, very simple Lambda that will act as a trigger on those rules. So when something happens, like an EC2 run instances API call occurs, that goes to Lambda. Lambda then just takes it and does an SNS publish into our SNS topic in the security account. And the only reason I had to do that was because there's no way to do cross-account trigger for CloudWatch event rules to go from SNS into to basically publish to an SNS topic in another account. So I just had to build a small Lambda to do that. But the CloudFormation template in all the other accounts, it's super easy. I don't have to worry about updating it too much. All the logic happens in our central security account. So I never have to worry about things breaking 58 times. They just break in our one central place, which, because my code is terrible, they often break. So then once the SNS publish occurs, CW catcher receives that message, sends it to CW EC2 or IM, depending on what it is. And then from there, you either remediate and or just alert the DevOps team and send an email to the account owner saying, hey, this resource was created, it's non-compliant, please follow up. Or we just remediate and say, hey, this is a non-compliant resource, we have taken care of it for you, it is now compliant, but your app might not work anymore. So that's the architecture diagram. This is just a quick screenshot of what an event looks like in Slack, and that's it. So some quick credit. Cloud Custodian, Andrew mentioned this. Cloud Custodian is really cool. It just didn't quite fit what I was looking for, but some of the stuff that they're doing is pretty awesome, so check it out. Squirrel bin, AWS account utils from Intuit, and the security blog. Definitely check out AWS Security Blog. Really, really good stuff there. All right. So we've got a few minutes for some questions, if anybody's got some questions.
Questions?
Well, he's got a mic coming to you.
Okay. Test, test.
So the code that you've written for all of this, is that all open source? Is that available?
Yeah, so the only part, and this may change in the future, but the only part that I'm planning on making open source is the single page app, the portal itself, with the compliance engine behind it. But that is not yet open source. I'm hoping in the next couple of months I can make it open source. The biggest holdup for me right now is kind of legal and just making sure my code is really OSS ready. And then outside of that, I need a cool name. So if anybody's got any ideas for names on the project, that'd be great. But yeah, chicken coop, I like it. But yeah, it will. That part will be. Some of the other parts, we'll see.
Any other questions?
Yes. So you mentioned no connectivity between accounts at this point, which really drives home the point that this is pretty much Linux-based, I guess. No Windows domain joined, anything like that.
Yeah, so none of the instances running any account is domain joined in any way to our managed data center. We're trying to stay away from Windows, and we're just leveraging a lot of Amazon Linux AMIs.
Okay.
And just going that route instead. Yeah. Any other questions? Great. Well, thanks again for coming out.